This is part 2. Use the value of the trigonometric function to evaluate the indicated functions. So we're going to be using the previous slides, the even and odd functions. So they give you cosine of t is equal to -3/4. They want you to compute cosine of -t. From what you saw in the previous slides, cosine of -t is equal to cosine of t. They want you to compute this right here. So it's just equal to, according to the formula, cosine of t. What is cosine of t? -3/4. That's the answer. Part B, secant of -t. You know that secant of -t is equal to positive secant of t. We know that cosine of t is equal to -3/4. So all we need to do is just take the reciprocal of cosine of t, and that's how we end up with -4/3. Moving on to the next slide. Same directions. This is what they give you. Sine of -t equals 3/8. They want you to compute this, sine of t. So if you look at this one's going to be a little bit tricky. We're going to be using this formula. Sine of t is equal to this, -1 times sine of -1 times sine of -t. Sine of -t is equal to this. And if you multiply negative sine of t times -1 is equal to sine of t. So now, what is sine of -t? Sine of -t was given to you, which is 3/8. That's why we multiply -1 times 3/8, and this is your answer. A little bit tricky, but you should be able to follow. Part B, cosecant of t. This is doing it the long way. Or the other way you can do is this relationship between cosecant and sine, the reciprocals of each other. So you can just, you already computed cosecant, you already computed sine of t, which is -3/8. Cosecant of t will be the reciprocal of that. You can go from there to there, using part A. This is 9. It says same directions. Cosine of t is equal to 4/5. And this one we need to compute. This one's a little more challenging. This is how we're going to start out this problem. I know that t is equal to 36.9 degrees. How do I know this? Because I can use the inverse for cosine, and I end up with 36.9. And notice that I need to be in degree mode in my calc in order to be able to get that. So now I'm looking at pi minus t. I know that pi is 180, so if I do 180 minus this angle, I know that I'm going to be in quadrant 2. So now, let me look at the unit circle and see, and let me look at this following pattern. Okay, let's say that I have pi over 6, and I'm looking at the x value, which is radical 3/2. Now I'm going to take this angle and take it away from pi. If I do that, if I take pi and take away pi over 6, I know I'm here. And notice that if this is radical 3/2, what is this? Just the negative of that. In the same manner, any angle here, if you do pi over 4, if you take, for t you take pi over 4, you do pi minus the angle pi over 4. The x value is radical 2/2. And for pi over 4, for pi minus pi over 4, I'm at 3 pi over 4. So I have negative radical 2/2 in the same manner, -1/2 over here, and over here is 1/2. So I'm going to be using that idea. Whatever this angle is positive, the x value is positive, but pi minus whatever that angle is just negative, positive, negative, positive, negative, and so forth. So that's why I know that cosine of pi minus t is going to be the negative of this. B, same directions, same angle t, and they're giving you 4/5 for cosine. And then I know that cosine of t plus pi, since t is 36.9 and is on the third quadrant. So I'm looking at a relationship between quadrant 1 and quadrant 2 between the angles. Notice that, excuse me, This is pi over 3, and if I add pi over 3 and pi, I end up over here. So there's a relationship between these two angles. If this is 1/2, the x value, what is the x value here? Negative 1/2. Look at this one as well. If you like, change the color. If I look at this one, this is pi over 4, and I add pi to it, I end up here. What is the x value? Here is radical 2 over 2. Over here is just negative. So given that, I know that since cosine of t is equal to 4/5, cosine of t plus pi is going to be negative 4/5. And this is the end of this lesson.